To get rid of the log of base 5, we're going to have to exponentiate with a base of 5. So we're going to say 5 raised to the log of base 5 of x to the third over 5x, right, equals 5 to the first. So log of base 5 of 5 is 1. We use the power rule to bring to x to the third over 5x to the bottom. So we have x to the third over 5x equals 5. So we can reduce this, right? We have x to the third on top over x, so we know that reduces to x to the second. So we have x squared over 5 equals 5. Multiply both sides by 5 to get rid of the 5 in the denominator. So we get x squared equals 25. And then take the square root of both sides and we get x equals plus or minus 5, right? So that means x equals 5 or x equals negative 5. So we know one of these two solutions is an extraneous solution. So we're going to go back to our original and we're going to look at our original and see, well, if I plugged in a negative 5 in here, like we're going to take the log of a negative number. So since we can't take a log of a negative number, we automatically know the negative 5, 1 is extraneous. So we can't just assume every time a number is negative, anytime we get a solution that's negative, that is automatically extraneous, because sometimes we have exponents that might cancel out the negativity, right? So if this was a square instead of a third root, then that actually would have made that non-negative, right? I also would have had to have a square over here or an even powered exponent. Right. So don't just count the negative ones always as the extraneous ones. You have to check to see which one, plug it back into the original, see what, and put in your calculator, see which one gives you a wrong answer. Okay? So any other questions from the homework? Yes, Brock. 11. All right, so 11. We have 7 minus the log of base 3 of 8x equals 2. So our first step, we have to get the log by itself, so we're going to subtract 7 from both sides. I had some people in other hours that move the log over and then move the 2 over. It's fine, however you want to do it. So I'm going to subtract 7 from both sides. That gives me the negative log. I can't read my writing. Is that a 3? Yes. Base 3, that's sad. Base 3 of 8x equals negative 5, right? But then I need to get rid of that negative, so I'm going to divide both sides by negative 1. So then I just have the log of base 3 of 8x equals 5. So since I have a logarithmic function and with base 3, I need to exponentiate it with the base of 3, or you could just rewrite it. So remember we learned about rewriting from logarithmic to exponential equations, right? So to rewrite this, I would rewrite it as what? 3 to the 5th power, right, equals 8x, right? So if I did that, 3 to the 5th equals 8x. Well, that's the same thing I would have gotten if I would have exponentiated 3 raised to this and 3 raised to that, right? I would get exactly the same thing because this would cancel out. So you guys see you've learned 2 different tools, 2 different methods, right, for solving these. The first one we worked a lot with is rewriting from exponential, right, to logarithmic form. So you can still use that. And then our last step here would be to divide both sides by 8. So then you have 3 to the 5th divided by 8 equals x. (14). All right, so 14, you have the natural log of 1 minus 3x plus 3 equals 9. So you need to get the natural log by itself. So we're going to subtract 3 from both sides. So then we get the natural log of 1 minus 3x equals 6. So since we have a natural log with base e, we're going to exponentiate with base e. Or if we know this is base e, we can do the same thing. E raised to the 6th power is going to equal 1 minus 3x, right? So either way you want to do it. So I'm going to go ahead and exponentiate e raised to this. I'm going to raise this side, e raised to the 6th. So e to the natural log is 1. Power rule brings us to the front, so we have 1 minus 3x equals e to the 6th. And then we just solve it. Subtract 1 and divide by -3. So then we get x equals e to the 6 minus the 1 divided by -3. Yep. So you just have to remember e and natural log go hand in hand, right? So we pretty much went through most of these problems. Is there any other ones that you want to go over? 15? All right. So we'll go over 15 and then we're going to do Newton's law of cooling. So let's look at 15. All right, so for 15 you have the log of 7x plus 4 equals 5. All right. So we need to get the log by itself, so we're going to subtract 4 from both sides. So you get the log of 7x equals 1. So this is the common log. Since there's no base given, we already know, or just assume it's base 10. So we know that if there's not one given, it's called the common log and it's base 10. So then we would just exponentiate with base 10. So we'd say 10 raised to the log of 7x equals 10 raised to the first power. So 10 log 10 is 1. So we get 7x equals 10 to the first, which is 10. So then we divide by 7, and we get x equals 10 over 7.